Okay, hello. So we will continue with the planning. The planning and the risk management will be our main topics today, and we are going to speak about planning. Basically, uh, nowadays there are two types of planning commonly used, and it depends on project or on the project type. Uh, the usual and classical way of planning is called waterfall planning. That we are planning from the top down, and we are not turning or going back. Uh, but uh, in, let's say, last decade, we are uh, we can see or we are witnessing rapidly rising usage of so-called agile approach. What's the difference between waterfall and agile? The agile approach is mostly used within the software projects or the projects where you can cheaply and quickly undo the previous changes. If you are, for example, building the house, and you will enter the raw building, and you decide that you don't like the layout of the building, it's really expensive to change the layout. So going back in the project is extremely expensive, and probably it's not going to happen. But within the software project, changing of the previous written code is simple, quick, and cheap. So you are allowed to take step backs and change the project. So therefore, nowadays we are commonly seeing two approaches. Which first of them, the classical one, is called waterfall approach or waterfall planning, and the second one is called agile planning. Uh, Within our project, we will speak about waterfall planning because at the beginning we have to plan the whole project. Basically, all subsidy project or all subsidized projects are planned using waterfall technique. So the ideal approaches or ideal tools for planning the waterfall technique or waterfall projects is so-called project breakdown structure, product breakdown structure, and work breakdown structure. How does the product breakdown structure work? We need to make sure that we are not going to forget about any activities within our project. Because if we forgot to count with the activity, uh, we will probably be out of budget at the end of the project or out of schedule at the end of the project, which is quite problematic. My personal opinion is that if you are unexperienced and you are preparing the project, don't be afraid at the end to multiply the costs and the required time by two. Actually, if you are doing it for the first time, don't be afraid to multiply it by three, because I'm more than sure that you will definitely forget about some activities and you will definitely forget about some costs. Uh, I'm doing projects for more than 10 years, and still at the end, I'm multiplying my budget and my required time at least by factor 1.5. So I'm increasing it for 50% at least, but I'm not afraid to increase it by 100%. Uh, from my own experience with the subsidy projects, I never have problem with budget, which was multiplied by two, like increased by two, because the people reviewing the subsidy applications are also project managers, and they understand that you need to be prepared to the risks, and uh, budget for the risks is, or any type of reserve is not eligible within the subsidies projects. Uh, Definitely, you cannot increase the budget, I don't know, by 1,000%, because the reviewer will know and they will reject your project based on the uh, overpricing. But 100% of 100% in reserve, uh, it's acceptable, at least from my own experience. So let's go back to the planning. We have our product or our goals. Uh, the product doesn't have to be physical. It can be service, but it's the product of the project. And the product uh, needs to be disassembled into the smaller pieces or break down to the smaller pieces, which can be described in terms of time, resources, and costs. So again, we are speaking about decomposition. Uh, let's take an example. Let's say that we are building the house. So what will be the product? What will be the products within the building of the house? Any opinions?
The product of the project is the builded structure, the house itself.
Okay, that's true. That's the overall product, but we need to decompose this product into the smaller pieces, which we are able to describe. Because if you came to the market, let's say to the Bauhaus, you cannot say, give me the material for one house. So you need to decompose the product into the smaller pieces, which can be described in terms of, let's say, activities. So the ideal level, if we are speaking about the house, the ideal level of the product breakdown structure, it's, let's say, the first product will be the paperwork. You need to obtain all the permissions. Uh, in Czech Republic, uh, to obtain the build permission or building permission, you need to provide the office, the building office, uh, with something between 30 and 40 signed documents. So you need to sign agreement from all the neighbors. You need the document from the electric company that the house is connectable to the grid. You need the same from the water providing company, uh, and so on and so on. At the end, you need about more than 30 signed documents. Okay, so the first product will be all the paperwork. The second product will be, let's say, foundations. The third product will be the raw building. The fourth product will be the roof. And, for example, windows. And then we will start to speak about uh, inside equipment, so the electricity, the plumbing, water, and stuff like this. So we are decomposing the project to the simpler goals. Actually, the product breakdown structure can be copied from the logical framework, which is the ideal starting tool about which we was speaking last time. When we have the products, so as you can see, the product is at the level, okay, I'm going to hire the electrician and the electrician will do the whole product for me. So let's say that our product breakdown structure will end at the level when the products are ideal for outsourcing, for example. So we have the products, but the products or product breakdown structure is not detailed or not in enough detail for us. So we need to break it more. But we are not breaking it to the other smaller products. We are breaking it into the activities. So the second level of breakdown is called work breakdown structure. I was speaking about electrification of the house with my example. So, what are the activities connected with electrification? So, first of all, we need to have plan like where the lights are supposed to be, and so on. Then we need to prepare the cables and stuff like this. So we need to make list of all the activities connected to the finishing of the semi product or of this specific product. Uh, Due to the so-called product-oriented planning, we will be sure that there are no activities which are not connected to the specific product. Because activities which are not connected to any product, there is no point to carry out these activities. Why? If they are not connected to any product. And again, if we have the product and there are no activities connected to the creation of this product, that means that we definitely forgot to count with some activities, and that we are missing the money for the activities in our budget. So therefore, the product-oriented planning, which is, for example, recommended by PRINCE2 methodology, is quite helpful in our case. Okay, this is just the example of the hierarchical structure of the product breakdown structure. Usually, for example, I am using the three-level structure. But if you are preparing the more complex project, feel free to use any number of levels you need to. But the three-level structure is quite common, or two-level structure within the simpler projects. The other way of looking at the product breakdown structure in smaller projects. So in the project you are going to prepare is from the point of so-called deliverables. What are the deliverables in your project? So let's say that you are preparing your project, the research project. What can be the deliverable within the research project? Try to answer. So you are preparing the research project. So what can be the deliverables? First of all, let's say that your project is based on the evaluation of the questionnaire, or no, that's too jumpy. Okay, first of all, you will do the systematical literature review. So you need to, let's say, identify the state of art. So the first deliverable of your project will be the systematic literature review. The second deliverable of your project will be the questionnaire design based on the systematic literature review. Third deliverable will be the questionnaire or dissemination of questionnaire itself. The fourth deliverable will be the evaluation of the questionnaire and the results. And the fifth deliverable will be discussion with the other authors and state of art. And based on these five deliverables, you are going to prepare the article into the journal, into the impacted journal. And if you write down your deliverables at the beginning, then it's pretty easy to prepare the project schedule and describe the project. So you know what you are going to deliver, what you are going to do, and then you are simply writing it as the continuous text, and you are writing at the beginning of the project, I'm going to research the state of art through the systematic literature review. Based on the systematic literature review, I am going to prepare the questionnaire, which will be distributed through proper channels. Uh, 3 months from the beginning, I'm going to evaluate the questionnaire, and based on the results, I'm going to prepare the article for the selected journal. So if you know the deliverables, it's quite easy to prepare so-called work packages and the schedule of the project. And because you are planning it based on the product, the framework is logical. You are not going to forget about nothing, and it's the actually easiest way. Therefore, it's called waterfall planning. That it's quite clear the sequence of the steps which needs to be taken. And it's also really easy for the evaluator to read it. The another recommendation I should give you is if you are preparing the project for subsidies or which are going to be reviewed and funded, always, really always read the instructions for the reviewer or instructions for the evaluator. In most type of programs, the instructions for the reviewer are freely accessible, and even if they are not meant for the applicant, they are extremely helpful, because in these instructions they are the most important information for you, and these are the information about what is going to be evaluated and how is going to be evaluated. So in the instruction manual for the reviewers, there is written, okay, we are going to distribute 20 points for, let's say, team composition. And if team consists same percentage of men and women, that means that you should award them 10 points. If the team consists of one young scientist, that means 5 points extra. And if you will read this evaluation, you can always prepare the project in manner that the project will obtain the maximum possible amount of points. Also, in this evaluation manual, it's common to be written, evaluate the goal of the project, which should be written in, let's say, chapter 4.3, which means that you have to make sure that the information the reviewer is looking for are written in the specific chapter. Okay, let's continue. How to create the work breakdown structure. Assemble the project team within the bigger projects. Distribute the sticky notes to team members. Team members record all tasks that occur to them. The sticky notes are sorted and pasted on the board. So actually, this is the graphical and team solution, which are using the board. the sticky notes, and we are using the timeline as well to prepare the basic orientation within the project. You don't have to do it this way. This is just the simple visual method. So it's up to you. Terminology. Activity. Activity is task or set of tasks being carried on by one specific person or one specific company in terms of outsourcing. Activity consumes time and resources, and we are able to say exactly how much time and how many resources are being consumed within one set of activity. Event, a condition that occurs after the completion of one or more activities. Event doesn't not consume the resources or time, and the previous activities must be completed. This is very similar with the process planning, that there are activities which are carriers of the work, and there are events which basically serves as the boundaries, and there are starting events, because if there is no starting event, the activity will never start, and there are end events, because without the end event, the activity will continue forever. So let's say that you are preparing your morning coffee. So there should be an event at the beginning. Why you start to prepare your own coffee? Because I decided to. So the starting event was your decision. Then you start boiling the water, and you are waiting for the event, in our case signal that the water is ready, and you can pour the water on the coffee. Milestone is event marking the significant progress. Network is graph with nodes and connectors, which shows links between activities. Path, a series of interconnected activities between two events. So what is the path within the preparation of coffee? So we start the boil water, and parallel with the boiling of the water, we are preparing the mug, we are inserting the coffee, we are preparing the sugar, for example, we are preparing the milk. So that's the path. And at the end of the path, the coffee is ready. Critical path. Critical path is important for the project, because any activity or any delay at the critical path results in the delay of the whole project. A path is composed of activities that do not have a time reserve. So if they are delayed, the whole project will be delayed. Critical time is the time required to perform all activities on a critical path. Work breakdown structure. Work breakdown structure is a detailed work schedule. It's a key document of the project and is the starting point for the management of all three main bases of the project. So the project time schedule, breakdown of selection of work and resources, and budget. How to elaborate activities in work breakdown structure in detail. Theoretically, it's possible to divide a complex activity into individual tasks. The division is considered small enough when the activity is completely clear and clearly defined. A clearly defined person is responsible for the activity. There are transparent costs and it's performed by one organizational unit. Okay, let's say with the example of work breakdown structure. XYZ company operates in the field of software engineering and won a contract for the production of new internet computer game, which is to be used in the marketing of clothing company. The company implements this order in the form of the Net 27 game project. This is a simple order that will make the company that will take the company several months and for which it will release only a handful of people. At X, epsilon, Z, they have clear procedures for creating different types of software and for project management as a whole. In each project, they distinguish between startup, planning, implementation, control, and final activities. As part of the startup activities, a project team will be set up, a project charter will be created, and this charter will be signed. Planning activities in this project will be somewhat limited as it is a small project without a major impact on the operation of the company. Only a plan of scope, time, cost, and risks will be created. Each of these plans must be created, then revised within the project team, and finally submitted to the stakeholders for approval. Uh, the implementation itself is the creation of graphical interface, functionality programming and testing. Several purely graphic designs will first be created for the graphical interface. Based on these suggestions, the customer chooses three for which a fully functional user environment will be created. From these three, the customer then chooses the final form of the application. Functional programming in the company takes place in 4 steps. First, all functions are programmed separately. Then the code is cleaned and these functions are interconnected and the code is cleaned again. Testing takes place both during the programming to test practical functionality and also after the creation of the entire program. The final testing requires first creating a test group, then familiarizing yourself with the program, testing itself, reporting, and modifying the program. During control activities, uh, project progress reports are generated, reports are distributed, and change management is performed. As a part of the final activities, a final report on the project is prepared which is submitted for approval to stakeholders. Then the project product is handed over and the entire project is completed. So from this page, try to prepare the work breakdown structure. So it's 9:40 and you can have 5 minutes to think about this and then we will connect it with the break. So think about this and we will start again at 10 o'clock and we will discuss the results. Okay, so I'm back. And do we have some results?
Yes, I guess.
Okay, so go ahead.
Okay, I will give a try. I identified three main deliverables. The first is graphical design, like pure graphical design. Second is programming and testing phase, and the last deliverable, main deliverable, is making a final report. We can mark this as completion of this. And then I divided the graphical phase into 1.1, which is making a few suggestions, then choice of three, and the final choice of the final form.
Okay, and the rest will be in the similar session, in the similar fashion.
Yeah.
Actually, I divided the programming and the testing into the two deliverables, but actually you can connect them as well. It's not
Okay.
problem at all. Okay, and also I edit the one section, the control activities, where the controlling in the project is being done. Let's take a look at the controlling. The controlling is really, really important part of the project. Actually, any time within the project, you have to be able to say where exactly are you in the project, how much of the work is finished, how much money is spent, uh, and be really careful about this even at the university. My one of my first experiences from the university project was uh, that I was responsible for the preparation of the new books within the faculty. And the project was extremely simple, that there was 5 people which were participating on the preparation of 3 books. And we have a year to finish. And at the end of the year, the books should be handed over to the university printing services, and the university printing service should take care about the printing of the book. And I was imagining, okay, that we agreed at the beginning of the year that we are going to prepare the books and that we are going to hand them over at the end of the year. So I prepared mine and 1 month before the deadline, I ask my colleagues to send me their books, so I will hand them over. And 1 month before the end of the project, I find out that I was the only one who finished my tasks and have the book ready. So uh, be careful about this. My recommendation is to check the project progress at least once every 3 months within the really simple project. And don't be afraid to check the progress every month or every 2 weeks within the more complex projects. Because if you let it be, you will find out after half a year that nothing is being done and that ending in time will be extremely problematic. But if you find out after 3 months that nothing is done, you can start to do something with it and you will still have time to finish in time. So that's about the control. Don't underestimate the project control. It's really essential. Okay, the schedule. The schedule gives us answer to question when. The aim of the time schedule is to organize all projects activities into a logically correct time sequence. To create a schedule, table of activities and estimated duration. You need to create a time sequence of activities, ideally in form of the Gantt chart. Uh, you are linking the activities, you can calculate the time reserves and determine the critical path, and then you can insert the milestones. Uh, there are three uh, types of logic within the time planning. It's called hard logic. The activity requires the start or the end of the predecessor. It is not possible to build a roof until the walls are standing. It is not possible to test a prototype until it is made. Or soft logic, completion of start of a previous activity is preferred but not necessarily required. It's bonus for the customer. Uh, so you need to do all the activities, uh, but they are not connected together. You can do it, for example, in parallel manner. And external logic. Uh, External logic links to external activities that the project team cannot influence. Software testing may be dependent on the delivery of hardware from an external supplier. The production of project might depend on the outcome of negotiations with suppliers. So you need to plan based on the external given time. It's called external logic. Parallelization of activities. It's really simple. Some steps may take place in parallel instead of sequentially. Key benefits is shortening the duration of the project. It's easier to include feedbacks, partial returns, and minimize conflicts between different functions in the team. But the problem is that in parallel manner, the resources, mostly the workers, may be overloaded. So you need to make sure that your employees are not overloaded if you are planning the activities in parallel manner. Uh, when you are planning the project within the Gantt chart, for example, using Microsoft Project, there are four links between activities. The first and the most common link is finish to start. That the first activity needs to finish before the second activity can start. So it's the most common connection finish to start. So the water needs to finish boiling before I can start to pour the water into my coffee. Finish to finish. The first activity needs to finish before the second activity finish as well, or to finish to second activity to finish as well. The practical example. Let's say that we are in the music concert and the finish of the music production means that we are not selling the beverages anymore. Start to finish means that the start of the first activity results into the finish of the second activity. Again, we have the music production and or music production or some sports match, and let's say that the start of the match means that you cannot bet on the result anymore. And start to start, again, the start of the first activity results into the start of the second activity as well. Okay, here we have another example. As a project manager, you have led the project to time planning. You have already completely defined the activities. Your task now is to sort from the beginning of the project to its end based on the list and a brief description of the activity. At the same time, it is necessary to show the logical links. In example, which activity is related to it and how. For each logical connection, it is necessary to state the method of sequencing and the type of logic, hard, soft, external. This project does not work with the duration of activities. Uh, the implemented project has the task of creation of prototype of the innovative product, and it is sub-project of the ABC product innovation project, which is included in the company's product portfolio innovation program. The input for the project is a complete specification from the design department. As part of the project, it will be necessary to produce all but one of the components that must be purchased, modify them in certain way, and then assemble and test the prototype. It is necessary to produce components A, B, both on machine K, C, D, both on machine L, E, and F, both on machine M. Each of the K, L, and M machines always has the capacity for only one component. so it is necessary to produce them gradually. Part G must be ordered from an external supplier. The prototype will be assembled as follows. First, components A and C are connected. Once this connection is started, it is also possible to connect component B. Next, it is necessary to connect components E and G, connected component F to the resulting structure. This creates two modules ABC and EFG. It is not necessary to paint the ABC module, but the company prefers to do the same. On the contrary, the EFG module must be painted unconditionally. Subsequently, both modules are allowed to dry. During this drying, the preparation of the connection via component D can already take place, regardless of the production status of component D. Once both modules have dried, the preparation are completed and component D is manufactured. All parts can be connected to obtain the final product. After its completion, it's time for testing. The beginning of the activity of reporting findings is also connected with its beginning. After the completion of both of these activities, any changes are made and the project is completed. So your goal is to write down uh, in graphical manner the connection of the activities. So what will be at the beginning? At the beginning, we need to start production of all of our parts. So we need to produce the components A, B, A, B, C, D, E, F, and we need to order the component G. And here we can see that when the component A is prepared and component C is prepared, they can be connected. When the component B is ready, it can be connected as well. So the final chart will look like this. Okay, uh, the next chart we will speak about is so-called Gantt chart. The Gantt chart is the really useful tool for creating a schedule. On the x-axis, there is the time. and the names of the activities are on the epsilon axis. The bars represents the duration of each activity. The individual lines or activities have clear links with each other, and it allows you to assign resources. Uh, Based on the Gantt chart, we can define the critical path. The critical path represents the shortest possible duration of the entire project, the time needed to complete all tasks in project. So uh, let's prepare another example and try to draw down the Gantt chart for this set of activities. Okay, I just find out that I don't have the Microsoft project on this computer, so I can show you the really simple way how to draw Gantt chart in the Microsoft Excel. So let's say that uh, each column is 5 minutes. So we have the activity A from the beginning. We have the same length of activity B from the beginning. We have the half length of activity C. I decided to use three colors because I don't want, because there's no way how to make connections between these activities. The activity D starts at the end of the activity A and takes 15 minutes. So I will use the same color for the activity D to show the connection. The activity E uh, starts at the end of the activity B and C. So we are waiting for both activities to finish, and it takes 10 minutes. It's same for the next activity, also waiting for both activities. And it's the same for next activity. So they are starting in parallel. The activity H is waiting for the activity C, and it's for 2 minutes. The activity I is waiting for activity G, so it starts here. And the J activity starts here. So here we have the Gantt chart for the previous example. And where is the critical path? Can you name me the activities which are on the critical path?
There are activities that are required for following activities, in my words.
Okay, but in this example, the activity A, the yellow activity, is on the critical path because they are connected and there is no reserve among them.
Yeah, I
Then,
agree.
then the green activity, this one, it's connected with this one, is connected with this one. And again, there is no reserve in this part. There is the reserve, it's here we have the reserve here. Also, we have the reserve here. Then in the red one, we have the reserve here. So these three activities or these four activities, three, are not on the critical part because there is the some type of reserve we can use. Okay. If we use some software support like Microsoft Project, the software will calculate the critical path and the time reserves for us. But we will show, I will show you how they are being calculated. So in each activity, or each activity is described by these 7 attributes. They are early start, early finish, late start, late finish, and at the beginning we know the name, the duration, and we are trying to calculate the reserve. How it can look like? It can look like this. So at the beginning, there is an activity with the zeros only. And we know that the activity A starts at the beginning. So in the upper left corner, we can see that the early start is 0. So we can start in the 0. Activity is called A. It takes 20 minutes. So we add 20 to the 0. So the earliest time possible when we can finish, it's 20 minutes. Okay, the activity D starts at the end of the activity A. So we copy the early start we copied the yearly finish value, the 20, into the yearly start value of the activity D. So the activity D can start at minute 20, takes 15 minutes, so it can finish at minute 35. The activity J needs the activity D and the activity E to be finished. So to the yearly start, we need to copy the higher number because we are waiting for both of them. In our case, it's 35. It takes 8 minutes. So we copy 43. So at the we make it to the end and we finish all the yearly starts and yearly finish boxes. And the late start and late finish boxes we are filling from the end. So the project is finished after 43 minutes. So the late finish is 43. Then we subtract the duration of the activity, and that's the late start. And when we subtract the late finish minus yearly finish, that's uh, our reserve. Do you see it and understand the picture?
Yeah, it's okay.
It should be quite simple. Actually, in practice, you should not have to be forced to calculate it manually, but you should know how it's being calculated. Uh, my recommendation is to use the project Libre. It's the freeware for project planning, and it's a really good copy of the Microsoft project, and it works well with the Microsoft Office. Okay, that's what I was speaking about. The really great tool is the Microsoft project, but the problem is that the last year the Microsoft project decided that they are not going to support the offline version of Microsoft project anymore, and they want to strongly support the cloud version of the Microsoft project within or connected to the Office 365. Uh, but the prices are quite high for using it within the university, and they are promoting the payment in fashion software as a service. So the price is about 6 euros, but I'm not sure if it's for a week or day. But we calculated last time at the Faculty of Economics, and we find out that the prices are really high in total. And the problem is that if you are paying just for the simple cloud version, the students can connect to the central server and modify the projects, but they are not allowed to create their own projects, which is useless for us because the lecturer will be forced to create a project for each student individually, so the student can modify his own project. So therefore, we decided to move on to some freeware version, and after the evaluation of possible solutions, we decided to continue with the software which is called Project Libre. This is how the Gantt chart looks, the original Gantt chart created in Microsoft Project. We can see on the left side, we can see the task names, the durations, start, end of the activity, and the predecessors. So basically, if you copy the table I was showing you in the example, if you copy it here, it will draw the graph for you, and it will highlight the critical path in red for you as well. Resources. Tasks and projects compete for resources. The goal of resource allocation is to optimize the use of limited resources. Uh, Compromises are always needed. We have the time limits and resource constraints. Let's say in an example, we all want to take exam at Wednesday before lunch, let's say from 10 o'clock till noon. And we want the capacity of the exam to be as high as possible. But there is not enough rooms with this capacity at the faculty. Therefore, we need to agree somehow on the schedule of the usage of the proper rooms. Resource assignment. Uh, the implementation of each activity needs resources, human resources, material resources, costs. Each resource must be assigned a cost to use it. By allocating resources and cost, the project budget is created. Again, if you are using Microsoft Project or the Project Libre, there is the second table called the resource allocation, and you will just allocate the resources to the activities, and the software will calculate the budget for you. Estimation of cost of activities. First of all, you need to identify resource requirements and costs for each activity. So the work resources, people and machines, where you are paying for the time you are using the activities. Workload utilization, material resources, cost resources, overheads. Accumulation of costs. So the direct costs are really simple. It's the labor resources, which is usually a hourly rate, continuously according to the percentage of activity completed. Materials, they are usually cost by piece, multiplied by number of pieces. Then we have costs for outsource activities and subcontracting. These are all called the direct costs, which are really, really simple and easy to calculate. But what about the indirect costs? Any ideas or any examples of the indirect costs which I have to pay and I cannot calculate them directly to the product, or I cannot allocate them directly to the product?
It's the energy for a power plant, for example, like for lighting and heating.
Okay, because I'm not able to say how many light I use to create one piece of the product.
Yeah.
Exactly, there is a huge number of the indirect costs, and actually nowadays at the university, or nowadays last 3 years, we are really strongly struggle with the indirect costs at the university level, because our indirect costs are calculated wrongly. That's my opinion. And it's problematic for our projects. So within your project you are preparing for, uh, you are using so-called flat rate for the calculation of indirect costs. Anybody knows what is the flat rate calculation? Flat rate calculation, anyone? Okay, so basically there are two approaches to calculate the indirect costs. And one of them, the simple one, is called flat rate, and the difficult and not really good at the university is called full cost model. The flat rate means that you calculate all your direct costs and you add the flat rate. In your project, I think the flat rate is 15%. So you will calculate all your direct costs. Let's say that your direct costs will be 1 million crowns within the 3 years. So the flat rate will be 150,000 crowns. And you need to prove the usage of the direct cost within your accounting. Let's say that if you say, okay, I'm going to buy the books for 100,000 crowns, then you need to prove that you really bought a books for 100,000 crowns. Same with the transportation expenses, same with the salaries. You need to prove that you really paid them. On the other hand, you don't have to prove what you did with the indirect costs. There is 150,000 crowns, which is yours, and you should use them for indirect costs. And you don't have to prove how you use them. Is it clear?
Yes.
Okay. And the second approach, which is not that lucky, but actually is being forced to use at the university, is so-called uh, full cost model. And the full cost model is based on some internal calculation within the university, and at the end of each year, the university creates the model for each faculty separately and calculates how much is their indirect costs. And surprisingly, the indirect costs are not the same within the university. So, for example, the indirect costs of the Faculty of Applied Sciences are more or less 20%. But the indirect costs of the Faculty of Economics are 60%. And indirect costs of Faculty of Design are 90%. And the simple question is, how is it possible? And simple answer is because it's calculated from the wrong numbers. It's calculated right, but from the wrong numbers. If you imagine, uh, there is the employee who is organizing the lecture, like me, for example. So if I will be the employee of the Faculty of Applied Sciences, my lecture will cost 1,000 crowns for 1 hour. Then 800 will be my salary, and 200 will cover all the expenses faculty have with organizing of my lecture. Okay? But if I do the same lecture in the same room, but under the Faculty of Economy, I will receive 400 crowns, and 600 crowns will be taken by the faculty to cover the expenses the faculty has with my lecture. And if I do the same lecture in the same room for the Faculty of Design, I will receive 100 crowns, and 800 crowns or 900 crowns will be taken to cover the expenses the faculty has with my lecture. On the one hand, this is completely crazy. On the other hand, it's due to the fact that the total amount of earnings is extremely different within each faculty. So let's say that if you are earning hundreds of millions a year and you need to pay an accountant, your percentage to cover the accountant is really small. If you are making almost no money a year as a Faculty of Design, your percentage to cover the same service will be extremely high. So therefore, for some faculties and some projects, the full cost model is really good and beneficial. but mostly it's difficult, it's unclear, and it's problematic. So if you encounter any project where you can decide if you are going to use the full cost model or the flat rate model, my advice is always go with the flat rate model because it's way simpler and way safer, even in the terms of late controls. We are still speaking about the project costs. I hope it's quite easy to understand that there are direct costs and indirect costs, which are also called overheads. Other costs, coverage of unidentified risks, bonuses and commissions, budget for difficult to predict effects, or some budget to cover risks. We call it project reserve. Be careful that in the vast majority of the subsidy projects, you cannot create the reserve. It is not eligible costs. Project budgeting. A budget is a plan for allocating resources to carry out project activities. Is prediction of required resources, quantity, when, costs. The budget connects the project with other goals of the organization. The budget is a tool of top management for monitoring and project management. Project costs are based on resource planning, cost estimation, cost budgeting, cost control. The project budget is the most effective tool for measuring a project. So the budget gives us an answer to question for how much. There are two approaches to cost estimation. The bottom-up method, the individual activities will be appreciated. The sum of costs of the activities creates the budget of the whole project. And then the top-down control, the total costs of the top-down methodology, the total cost of the project is given. It's divided into the work packages and it's corrected by the bottom-up method. Top-down budgeting is based on the collective assessment and experience of top and middle management. So let's say that top-down budgeting is really quick and easy, but you need to have experience from previous similar, this is the important word, the previous similar project. Otherwise, you are not able to use the top-down budgeting. The total cost of the project is estimated based on the cost of the main tasks. The benefits of this approach is accuracy of the overall budget estimation, and we do not have to deal with inaccuracies in the financing of less important tasks. So basically, it's really fast cheap and efficient, and is quite accurate in total. Bottom-up budgeting. Activities are defined by the work breakdown structure or an action plan. The persons responsible for carrying out the activities estimate the resource requirements. Advantage. It's more accurate for the all levels, even less important activities. The disadvantage of this approach is that you are risking of overlook some activities, then that the total budget will not be that accurate, which will definitely happen. Actually, if I'm speaking about bigger project, let's say for 1 year, during my work, I never estimated the budget right. And actually, I never met no one who estimated the budget right. But as I said before, we are multiplying our estimation by 1.5 or 2, and then our estimations are right, and we carrying out the projects without the problems, even with the overlook activities. Mostly common is so-called combined approach. It's the interaction of bottom-up estimation and top-down adjustment. There are other tools you can use within the creating the budget. Changes in resource costs, that's called sensitivity analysis. You can change all estimates by the same percentage and identify changes in total costs. And this will help you to identify the inputs to which the total costs are most sensitive. There are a lot of waste within the project or wasted money. The problem is fluctuation of team members and organization climate as well. A resource overload. The problem is if some concurrent activities use the same resource, it may be overloaded. Overload can be compensated by the overtime work, rescheduling the activities, or providing additional resources. Resources that are assigned to non-critical path tasks can be used on the critical path. Microsoft Project allows you to perform automatic alignment. It usually leads to the extension of the project, which could be problematic. Resources may be overloaded during the simultaneous course of several projects. Then their allocation is decided at a higher level according to the project priorities, which is one of the roles of the project office. Within the Microsoft project is called multi-design. Paired method is second most commonly used method of estimation of duration of activities. uh, which use the beta distribution. It's really simple. Uh, you will use three estimations and you will calculate the average based on these three estimations. So you will use the optimistic estimate, which is considered the shortest duration of the activity with hypothetical frequency of 1 to 100. Then we will use the mode, the most probable estimate of the duration of the activity, and we will use the pessimistic estimate, the longest duration of the activity. And then the calculation is simple. We will make the average from one op, from one optimistic, four averages, and one pessimistic divided by 6. So we will make the average. And this should be more accurate than simple average value. So let's move to another example. And in this example, we will decide how are we going to estimate, how are we going to estimate the costs. Uh, we can estimate the costs from experience. We can estimate the cost from analogies with the older projects. And we can estimate the cost by the expert analysis. So, company currently operates in the video game industry where it moved from the business software and industry. It differs significantly from the video game industry, and the experience from it can rarely be used. The aim of the implemented project is to create a new computer game. The project remains to estimate the duration and the cost for game physics programming, creation, a graphical menu interface, audio recording of all dialogues, packaging design, and creation of web pages. So far, the company has mainly implemented projects in the field for mobile phones. It has no experience with the game physics. The user environment in business applications that the company previously created cost average of 100,000 Czech crowns and takes 30 days of work. However, the user interface has a minimum in common with game physics. The main developer estimates the extent of the required code at 50,000 lines. One line of business application code comes on average for 50 crowns and it takes 20 minutes. There is no calculation for one line of game physics code. So, what do you mean about estimation with the game physics? The problem within this example is that there is no experience with the physics. There are no analogous activities in other projects. And it is clearly stated that the user environment is not related to physics. Likewise, parametric estimation cannot be used because there are no historical data for one line of game code. All that remains is to ask an expert for estimate. The graphical interface is a discipline that is common to many types of software. Comparable methods are used for the graphical interface of business applications and computer games. From its 10 years of experience in the field of business applications, the company knows that the creation of graphical interface which will cost an average of 50,000 crowns and 10 days of work. The interface design contains a total of 100 components. The company has also implemented one project in the video game industry where it created an interface with 50 components in 8 days at cost of 30,000 crowns. Here we will use the analogy estimation for the graphical interface because the company has a lot of experience and comparable methods are used. Parametric estimation, on the other hand, cannot be used because there is the only one data point available. A large amount of historical data is needed for parametric estimation, not just one experience from one project. Audio recordings is also a complete novelty for the company. In total, you will need to record 30 minutes of dialogue for the entire game. For this purpose, the company has hired a sound studio that will provide actors and equipment. According to the studio, 1 minute in the recording studio will cost 100 crowns. But 1 minute of the final dialogue requires an average of 5 minutes in the recording studio. The studio recommends setting aside at least 3 days for the entire recording process. Sound effects in business applications, which company developed earlier, averaged 5,000 per application. There, however, they work with far less sophisticated technology and far less scope. So, in fact, an expert estimate has already been made for sound recordings. Respectively, the data for parametric estimation were expertly determined. We assume that the studio has enough experience in the field. We accept his estimate of the duration of 3 days. We get the cost estimate by multiplying the required number of minutes. In our case, 30 minutes in total, but 1 minute in total takes 5 minutes of recording, which is 150 minutes. So if we multiply it by the minute rate, it's 15,000 Czech crowns. The estimation of analogies cannot be used because in previous project it was the different technique and scope. The company has a stable process for packaging design, which is no different for a business application and computer games. This process is assigned to cost 15,000 crowns and take 12 days in the quality manual. The packaging created so far had an average of 42% of the red color. If the price of each package created was calculated according to share of red, it would be found that each percentage of a red comes to 200 crowns. For the packaging to be designed in the project, an estimation of 18% of red color. The packaging design is based on the quality manual from which the data can be taken. It can be assumed that the analogy will be of sufficient quality in the process if the process is standardized. The information about the color red is completely worthless and it's intended only for confusion. Unfortunately, in reality, only the data that is to be worked with is never available. There are always far more available data and information you need to process before you will be able to choose the essentials. To create the website, the company hired an external company which declares a price of 10,000 crowns and delivery in 16 days. However, company always hires this external company and already knows from many years of experience that cost will always increase about 20% and delivery times will be extended as much as 50%. So here we can follow the analogy of the past when creating the web pages, and we can adjust the estimation from the previous experience with the supplier. So we are moving further into the cost benefit analysis. The first and most commonly used tool within the cost benefit analysis is payback time. The payback time is the period for which the cash inflows from an investment offset the initial capital for the expenditure of the investment. For example, uh, an investment into new facility cost 1 million crowns, but this facility save 100 crowns a year on operation. What is the payback period of this investment? Anyone? What is the payback period of this investment?
10 years.
Okay. But this is really simple and quick calculation. Do you see any problem within this calculation? The problem of this calculation is that 100,000 crowns today doesn't have the same value as 100,000 crowns 10 years from now. Why?
Because of the inflation. I
Yes.
don't know the
For
English word.
example, for example, because of the inflation. And how much is the inflation in average?
Something like 2 or 3%.
Okay, something like 2 or 3%. So if we make an easy calculation, so in 5 years, the value of the 100,000 will be decreased by 15,000. So in 5 years, we will lose a little bit less than 15%. We will lose about 14%. So we have to calculate with the inflation, but not with the inflation only. Uh, the more accurate, way how to calculate the cost benefit analysis is so-called net present value. So there is another example. At the beginning of the first year, we will buy a machine for 100,000, which will bring 40,000 profit every year for the following 4 years. At the end of the fourth year, the machine will be sold for 20,000. We will use the 10% interest rate for discounting. Uh, Here you can see that we are using the interest rate, which is actually 3 or 4 times higher than the inflation you mentioned. Why? The interest rate is calculated based on what can I do with the money? Is there any uh, better alternative to spend my money? And am I able to make more by spending the money otherwise? So the not inflation, the interest rate is set it internally by the company top management. And to be honest, uh, the 10% interest rate is quite low. In average, at least from my own experience, it is really something between 10 and 20%. So here we can see how we are calculating the net present value. And here you can see it on the practical example. If we simply add these revenues and expenses, we will find that we will earn a total of 80,000 Czech crowns by investing 100,000 and then making the 40,000 profits. However, taking into account the time factor using a 10% interest rate, it follows that the current return of the investment will be only 40,000 Czech crowns. So the project is okay when the net present value is higher than the zero. But as you can see, due to the interest rate, the net present value is way lower than the classical calculations of the payback period or payback time. There is another parameter we are using, which is called internal rate of return. And our goal is that the internal rate of return will be higher than zero. Project measurement and evaluation quality. So we need to ask about the project control. Why the project control is necessary? Because we need to know what's going on within the project, and there is the another part of the project management which is called change management. The change is integral part of the project. Therefore, it will be really rare that you will participate in the project where will be no changes. Ideally, you need to agree at the beginning how the changes are going to be managed, who are going to do it, who are going to pay for it. So it's quite difficult. So first of all, you need to manage the created project plan. So first tool is the regular view of the plan. Be touch with people, update the plans, and check the plan updates. All these activities led to the project being completed on time and with approved budget. There will be at least one change in each project. Change is a permanent part of project management. All projects are subject to change and will end differently than originally planned. Quickly and project monitoring assumes that quickly and timely capture of the trend of the project development. There will be activities that tend to exceed the budget. You need to identify them at the beginning and try to do something about them. You need to reveal activities that are not done, and you need to monitor the quality of deliverables or deliveries. Again, the project monitoring enable timely design, discussion, and implementation of corrective actions. Interventions carried out from a critical path, work overtime, change to improve the processes, work with the team members. working environment, convince people, and discuss additional resources if necessary. When the costs are rising, you need to compare planned costs and actual costs. You need to compare what should have been done according to a plan and what was actually done. Determine the added value, compare added value with the actual costs, and compare the added value with the planned costs. These activities are called earned value analysis. So the earned value analysis is analysis of the actually created value. It compares the planned work with what was actually completed. It will allow us to express how cost, schedule, and work done increase and progress with the project plan. Prerequisites for earned value analysis success. These are accurate and timely reporting of work performed on the project, reporting the status of tasks, accurate and clear identification in the cost structure, bookkeeping, accurate valuation of individual activities and work, methodology for determining the degree of work in progress, values of work in progress, properly compiled detailed breakdown of work breakdown structure work, properly complied schedule, speed of processing the necessary data. There are four basic terms within the earned value analysis. First is BAC, which means budget and at competition. Then planned value, AC, actual costs, and earned value. Earned value is percentage of work in progress multiplied by total budget costs, budget at completion. Then we are calculating two indexes, which they are called cost performance index and schedule performance index. These two indexes just an answer about the progress of the project. So the cost variance is earned value minus actual costs. Schedule variance is earned value minus planned value. Cost performance index is earned value divided by the actual costs. Schedule performance index, then it's earned value divided by the planned value. So when the cost performance index is equal to 1, that means that we are exactly where we should be in terms of cost spending. And schedule performance index, if it's equal to 1, that means that we are exactly where we should be in terms of time or schedule. Estimate to complete the project is budget at competition divided by the cost performance index. And variance at competition is budget at competition minus estimate to complete the project. Here we can see the planned value, and here we can see the other values. So values in progress, so-called earned value, and actual cost according to the work report. So here we can see that the planned cost, the planned value, is same. Actual cost and earned value. So we can calculate the schedule variance is minus 6,000. The cost variance is minus 7,000, which means that schedule performance index is less than 1, and cost performance index is as well less than 1, which means that we are delayed due to the schedule, and our expenditures or actual costs exceeds the budget in the given time. Here you can see it more clearly. Prerequisites for successful project value add is accurate and timely reporting of work performed on the project, reporting the status of each task, accurate and clear identification in the cost structure, accurate evaluation of individual activities, methodology for determining the degree of work in progress, values of work in progress, properly compiled detailed breakdown, properly compiled schedule, speed of processing the necessary data. So now let's speak about managing the extent of change. What is the definition of scope? Scope is everything that makes up the content and boundaries of a project, defines what will be delivered and what will be not delivered. Changes are inevitable, but they are one of the main reasons for the project failure. Active change management is the key for the project success. So why do we need change management? Why there are changes within the project? Most of the changes are due to external changes, some legislation or regulation, for example, or internal project problems. Input requirements are missing, new requirements arises, misunderstanding of requirements, technical problems, or, and this is the most common, are resource issues, mostly with the personnel. Let's categorize the changes. The class 1 changes are significant consequences which will affect the three imperatives: the time, cost, and resources. the class 1 changes needs to be approved by the statutory body of the project. Class 2 changes are significant consequences which affect the organization of the project. But they do not affect the three imperatives of the project. They need to be approved by the project steering committee or the project board. Class 3, less significant consequences. They do not affect the three imperatives of the organization of the project. They need to be approved by the project manager. We are almost at the end. We just have to speak about the conflict management and about the risk management. If there are some problems or conflicts, you should always try to find the cause. There are number of techniques for resolving conflicts. For example, Ishikawa's diagram. It's called also the herringbone diagram, fishbone diagram, or the analysis of the root cause, Pareto analysis, theory of constraint, 8D, 5Y. There are number of methods you can use. These methods actually are not the part of our seminar, so I'm not going to speak about them. Another, for my opinion, really important thing is that the project manager cannot share the information about the reserves and the schedule and the budget with his employees. Because there are two approaches we are facing, or two problems we are facing in practice, and they are called the student syndrome and the Parkinson's project law. The student syndrome means that the reserve is used up before it even starts working on the activity. So the students usually starts working when it's absolutely necessary. So for example, if you have 1 year to complete your diploma thesis, you are not starting the first day. Finish your diploma thesis in 1 month and then take 11 months off. You estimate that you are able to finish your work in 1 month. So you will firstly, or most of the students will firstly take 11 months off, and then they will start working on their thesis. So that's the student syndrome. The second is Parkinson's project law. The Parkinson's project law is that the activity lasts at least as long as it has an allocated time interval. So if you give somebody a task and you will tell him, okay, this task will take 3 days, the employee will always do the task in 3 days at least. Nobody will come after 1 hour and tell you, okay, I'm finished. Can you give me another task? Therefore, try not to share the information about the time and the budget with the employees or with the people you are working on the project with. try to motivate the people not for the given date, but for the speed. Organize the project as a relay. Watch the work when it will be. It is inappropriate how much is done. You should take people's reserves and sell them. Actually, this is not good advice for you for internal projects within the university, but it's worthy advice. So, our last chapter we are supposed to speak about today is risks and opportunities. Risk is possibility or probability of loss, the possibility of events that prevent the achievement of goals, or the danger of negative deviation from the set goals. In projects, we commonly use just the pure risk, which is the negative side of the risks, or it's also called net risk. And the business risks has the negative and the positive side as well. The threat is a source of a potential damage. A risk is the possibility uh, that threat will cause loss or damage. The risk assessment determines in terms of the probability and degree of impact what can happen bad. The risk management is comprehensive, long-term and systematic rules how to approach the risk. So the risk classification, we have the business risk or the pure risk or the net risk, systematic and specific, inner or outer, uncontrollable, controllable and uncontrollable. Sorry. In the preparation and implementation phase or in the operation phase. And we can also further devise the risk according to the material content. So we can have the subjective risks. They depend on the activities of the company. For example, insufficient managerial skills, technical and economic ignorance, unqualification of staff, negligence, irresponsibility, small ability to adapt management to change in conditions. Or we have the objective risk, which are independent on the company activities, which are natural causes and disasters, political events, macroeconomic changes, or social pathological phenomenon. Then we have the controllable risks and uncontrollable risks. So controllable risks of accidents can be reduced by safety equipment, a risk of product price quality or cost reduction, or for example, a risk of natural events by insurance. Uncontrollable is, for example, the political situation, the taxes and the interests. They are depending on the economic development, and the distinction is made between systematic risks, which are affecting the entire economy, and specific risks to the specific field, company, or project. Another classification is operational risks, which are accidents of machines or systems, accidents, supply errors, strikes, market risks, which cover sales, prices, services, good name, investment, investing money in investment projects, securities, medical risk, for example, accident, occupational diseases, innovation or innovative risks, introduction of new products, technologies, financial risk, insolvency, or overall business risk, which is overall success reflected in the market value of the company. Benefits of using the risk management. It's better communication, fewer repairs and remakes, a reduction of financial and time costs, earlier identification of deficiencies and incorrect specifications, fewer unexpected events, less chaos, and primarily lower the project risks. Risk identification. Check the to-do list and the schedules, or use the checklists because probably your project is not the first project of the first same project. Discuss with the experts. Risk assessment. Determination of tolerance levels, assigning probabilities to individual risks, allocation of costs to individual risks, prioritization of individual risks, creation of risk plans. Based on the analysis, you need to recognize the procedures for the individual risks, setting active, reserve, or mitigation plans, mitigate the risk by taking actions beforehand, mitigate the risk by reducing the consequences after it occurs, which is called reducing the impact of the risks, respond to the risk with a reserve plan, and monitor the risks. In projects, we are using the so-called semi-quantitative risk assessment. So we will identify the risk and then we will evaluate the risks on the two scales in the table, which is consequence level for the project and likelihood of the risks that the risk will arise. And actually, we have basically four approaches to the risks. The risk map, we can identify the risks somewhere on the risk map, which risks A and D in this example we can ignore. We need to prepare the plan what to do with the risk E and B, and we cannot launch the project where when there is the risk C, the red risk, which is very probable or highly probable in this case, and with huge or catastrophic influence at the project. So what can we do with the risk C? What are the possible approaches for the risk control? Let's say that the risk C is the probability of fire within our building. What we can do about the fire inside the building?
We must put, for instance, fire extinguishers everywhere.
Okay. And the fire extinguisher uh, is influencing what? The probability or the impact?
The impact.
Okay, so the fire extinguisher is so-called a reactive approach. So when the risk occurs, we will react and we will decrease the impact. So the one approach is so-called reactive approaches. Can we decrease the probability of fire somehow?
We can control the working place, for example.
Okay. We can forbid the manipulation with the open fire. We can use non-flammable materials. So definitely we can decrease the probability. But we need to decrease the probability before. So that's called preventive actions. So we have preventive actions or reactive actions. Okay, so we have two sets of actions, but as I said before, there are four sets of actions. What else I can do with the fire?
Like in terms of preventive or reactive
No,
approach.
no, another approach than prevention or a reaction.
Okay.
What are you doing when you are going for the vacation and you want to make sure that if something happened to you, somebody will cover the damage?
Insurance.
Okay, so the insurance means that you transfer this risk to another one, to the third subject. So you can transfer your risk to the third subject, but usually the third subject wants you to pay for it. So you can pay the third subject to take your risks. The most common approach is insurance, that the insurance company is paid to take your risks. And actually is the most common approach within the projects. And the last one is that you refuse to take the risk and you have to cancel the project, or uh, you want to take the project because the potential benefit from the project is high for you, or there is the other reason you need to take the risk, so you can accept the risk. And the only way you can do within the acceptance of the risks is that you will prepare the budget to cover the losses. You can do nothing with the risk, so you have to be prepared that you will pay all the losses by yourself. So there are four approaches: prevention, the reaction, transfer to the third party, and acceptance. And the acceptance can be divided. I accept that I cannot do nothing with the risk, therefore I'm not going to launch the project. Or I accept that I cannot do nothing with the risks and I'm launching the project and I'm ready to pay for the damage, or for I'm ready to pay all the losses. We use some basic tools within the project management Within the risk management, the most common is a risk catalog, which helps us to sort all the risks. Then we are using the sensitivity analysis, which helps us to define which risks are significant for our projects and which risk we can ignore. We are using the cognitive maps as well and the yearly warning systems, which will give us information about risk in advance. Okay, and that's it from my side. So now it's time for your questions. Okay, if there are not any questions from your side, that's all for today. And I hope you will use your new knowledge and experience in your further projects.